Hi children, welcome to today's discussion on concurrent lines. Let's start this session with a small activity. Draw any 3 line segments as you wish. Here are few such examples you might have drawn. Lines with no intersecting point, or lines with one intersecting point, or lines with 2 intersecting points, or lines with 3 intersecting points. If 3 or more lines share a single point in common, then they are called as concurrent lines, and the mutual point of intersection is called as the point of concurrency. The term concurrent lines is commonly used in triangles. The 4 most famous concurrent lines found in a triangle are the 3 medians, the 3 altitudes, the 3 perpendicular bisectors, and the 3 angle bisectors. The point where these 3 pairs of lines meet are named as the centroid, orthocenter, circumcenter, and the incenter. These 4 centers are commonly called as the triangle centers. All good learning starts with vocabulary. So, let's learn the meaning of these terms one by one. The first one is the median. Median is a segment from the midpoint of a side to its opposite vertex. The point where the medians meet is the centroid of the triangle. It is denoted by the letter G. Now, let's discuss about their properties. If you watch the last part of the video closely, you could observe that on each median, the distance from the vertex to the centroid is twice the distance from the centroid to the midpoint of the opposite side. The second important feature of a centroid is that it serves as the center of gravity or the center of mass of the triangle. In other words, it is the centermost point or the balancing point of the triangle. Next, let's take up the area. Each median divides the triangle into 2 smaller triangles of equal area. So, the 3 medians divide the triangle into 6 small triangles of equal area. In this video, you can find that the base and the height of all the triangles are equal. So naturally the areas will also be equal. Next, let's pass on to altitudes. A perpendicular that is drawn from a vertex to its opposite side or the extension of the opposite side is called an altitude of the triangle. The point where three altitudes coincide is the orthocenter of the triangle. It is denoted by the letter H. Both medians and altitudes have one feature in common. If three sides of a triangle are equal, then the three medians are equal in length. So are the altitudes. If two sides are equal, then two of the lengths are equal. And in a scalene triangle, all the lengths are unequal. The third one is the perpendicular bisector. When two lines create equal angles, when they meet, then they are perpendicular. A segment which divides an angle or a line into two equal halves, then it is its bisector. Putting these together, a perpendicular bisector is a segment that is perpendicular to a side at its midpoint. The three perpendicular bisectors cross at the circumcenter of the triangle. It is denoted by the letter S. The circumcenter is the center of the circle that can be circumscribed around the triangle. That is, the circle touches the vertices of the triangle. Here, the distance between the circumcenter and the vertices always remain the same. The last one are the angle bisectors. A segment from the vertex of the triangle that bisects that angle is its angle bisector. These three angle bisectors pass through the incenter of the triangle. The incenter is the center of the circle that is inscribed inside a triangle. In other words, the circle touches the sides of a triangle. The incenter is equidistant from the sides of the triangle. Now, let's try to combine all these four triangle centers in full. We are going to observe their location in three different types of triangles. Let's start with the acute angle triangle. Here, all four of them lie inside the triangle. Now, if I make this triangle a right triangle, Then the orthocenter moves to the vertex of the right angle, and the circumcenter moves to the midpoint of the hypotenuse, while the other two remain inside. When the triangle becomes obtuse, orthocenter and circumcenter move outside, while the other two still remain inside. Now, let's come to the final part of our discussion on classic triangle centers. The mathematician you see is Leonhard Euler, who discovered the famous Euler line. Triangle is considered as one of the crowning achievements of mathematics, and the Euler line is one of its finest ornaments. Euler stated that in any non-equilateral triangle, the orthocenter, the centroid, and the circumcenter lie on a straight line. When the triangle is equilateral, all these points coincide each other at a point which is equidistant from the vertices of the triangle. After learning all this, our biggest confusion starts here. We confuse ourselves with the name of the concurrent line and its corresponding angle center. Here is an easy sentence to remember them. Interesting, isn't it? Finally, before we end up this session, here is a nutshell of what we have discussed in this session. Thank you, children.